This is an episode of the fidget spinner explanation video series called The Fearful Backflip. And if this is the first video you're watching in the series, I suggest you click on my face or in the description below. That brings you to the intro video talking about what this whole thing is and all the cool experiments. But if this isn't your first video, then I suggest you take a seat and hold on tight because it's about to get flippin' awesome. You know, everyone wants to know how to do a backflip, but no one actually does a backflip. I haven't stretched yet. Anyways, here's how the fearful backflip works. Imagine the fidget spinner is me doing the backflip because I've retired, and so I'm spinning the fidget spinner, and then I want to give it a nice little rotation, like a and that'll kind of make the fidget spinner spin back. But the thing is, if you actually try it and you do it, you can't. You just you can't. Okay. No. Okay. Yeah, you just can't because, well, the simple answer is conservation of angular momentum. But what does that mean? Okay. So, from your perspective, the fidget spinner is spinning, and then it's not focusing. Okay, so if I spin it, it doesn't flip, and I'm not like faking not doing the flip. It just physically cannot. And let me explain why, okay? For my previous video, if you've seen, I've labeled these colors just so that it's easier to see which circle I'm talking about, and this is a force vector, so if I'm like pushing yay, then this force direction is pushing there. So, while this thing is flipping in the air, you'd think that it would rotate all the way, or something like that. But the thing is, if you see this pink thing and I flip it on the way up, right? There should be a force vector pushing up, and as it spins, it should carry the thing all the way around and basically spin, right? But the funny thing is, while this pink thing is spinning, it actually goes to the bottom. And while it's spinning this way, there's still a force vector going that way. And so when this thing spins, the pink thing spins from top to bottom, and top to bottom, this force vector goes from top to bottom, and it, the forces like cancel each other out, if that makes sense. And that's same for the orange one. When the orange one's at the top, it pushes to up, and then when it's down, it also pushes the other way to prevent the fidget spinner from actually rotating. And so the whole thing gets like canceled out, if you may. And so I think that is a pretty decent explanation, intuitive explanation of why it doesn't flip. And you're thinking to yourself, Michael, why do I need to know this? And the answer is, you don't. But it's cool. I mean, think of it. Imagine you're a helicopter, right? You know, helicopters have this thing where they don't actually flip over very easily because, well, this fidget spinner is kind of like a demonstration of a helicopter. It doesn't flip over very easily. I mean, some helicopters do because there's enough lift. But on a very general level, they can't flip because of the conservation of angular momentum. And that's some deep physics stuff. But in short, if you don't understand, you can ask me in the comments below. And what I challenge you to do is talk to one of your friends who have a fidget spinner and you want to convince them that you're cool by teaching them some physics. Well, you're just gonna best hope that they're gonna fly with it. Good one, eh?